Good morning, students. In the last class, we have discussed about the loudness of sound. So, today we will discuss about pitch of sound. So, did you ever observe that some sounds are very shrill and some sounds are uh, grave? So in shrill means actually in Hindi shrill means patla and grave means mota. So generally male voices are generally grave, but female voices are very shrill. So why a voice is shrill and why another voice is grave? So pitch is that characteristics of a sound the which differentiate between a shrill sound from a grave sound. Okay, so the definition of pitch is the pitch is the characteristics of a sound wave which determines the sharpness or shrillness of a sound wave. So you know that the voice of a tiger of a lion is very grave, but voice of a bird is very shrill. Now this pitch is depends on the frequency of sound or frequency or vibrating body. So here in this picture, in the left side you have a low frequency wave. Okay, why it is low frequency? Because frequency means what? Frequency means number of complete oscillations or vibration, number of complete oscillation or vibration per second. So in the here here in the left side you have only three complete waves, one, two, or three. Okay. But in the right side you have how much waves? One, two, the complete wave, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Okay, so right side sound is very high frequency sound. Now 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 the relation between the frequency and pitch is the high frequency sounds are generally have high pitched sound. So high frequency sounds are generally high pitched. Okay, high pitched sound means the sound is shrill. Okay, shrill means patla. So high frequency sounds are generally shrill. So if you have a high pitched sound, that means if you have a high frequency sound, that means it has high pitched. Its sound is high pitched sound. And if you have low frequency wave, then its sound is low pitched. Now, now besides frequency, the pitch is also depends on the length of a vibrating ear column. Now, the pitch of a sound is depends on the length of vibrating air column. Now, suppose you have two flutes. Okay, so the first flute is very shorter in length, but the second flute is very longer in length. Okay, for this first flute, this second flute, but the width of these two flutes are same. Now the first flute has the first flute has high pitch sound, but the second flute has very low pitch sound, because pitch of sound is increases with the decrease in length of air column. Okay, so if you have two flutes, so the shorter flute will have high pitch sound. Okay, that means it has shrill sound, more shrill sound. Now the third point is thickness of the vibrating string. Suppose you have two guitars. Okay, this is your first guitar and this is your second guitar. Okay. Now the first guitar has thinner strings. Okay, and the second guitar has thicker strings. Now the first guitar will produce a high pitch sound. Okay, that means it will produce a shrill sound. But this second flute, which has the so first wave has thinner, it will produce high pitch sound. But the second flute which has thicker strings, it will produce a low pitch sound. Okay, so the if the vibrating string has the thinner the thinner string, then it will produce a high pitch sound, and if it is has thicker string, then it will produce high low pitch sound. Okay, it will produce a second will produce low pitch sound, first will produce high pitch sound. So that means the first sound of fast guitar is very shrill. Now the fourth point is length of the vibrating string. Suppose you have two guitars, and the length of first guitar is, or the second guitar is very long. Okay, the second guitar has very longer strings, but the first guitar has shorter strings. Okay, now the second guitar will produce a lower pitch sound. Okay, but the first guitar will produce a higher pitch sound because length and the length of the vibrating string and the pitch is directly proportional. That means if you increase the length, sorry, inversely proportional. If you increase the length, then the pitch will decrease. If you decrease the length, then the pitch will increase. Okay, now quality or timbre. Now what is quality? Uh, Suppose you have two sound waves. Okay, their amplitude and frequency are same, but these two sounds having same amplitude and same frequency, their sound can be different. Okay, it depends on its quality. Okay, it depends on the quality. Suppose you have, okay, suppose you have a tree has many fruits. Okay, but the size, color and shape cannot be same of the two, cannot same of the two fruits. Okay, one fruit can be darker in shape, one fruit is another, can be another color. Okay, lighter in color. Okay, and their taste can be vary. So similar in case of sound waves, if two waves if the sound wave has same amplitude and same frequency, then also their sound can be different. It's called its quality actually. So quality is defined as the property which distinguishes between two sound of two different musical instruments having the same pitch and loudness is called quality or of sound or timbre. Okay, now what is audible sound and what is inaudible sounds? Now our human now here human eye human yeah, our human mind cannot distinguish, cannot hear all the sounds. Okay, how we can hear, our brain can process only the sound which are in the range between 20 hertz to 20,000 hertz. Okay, so we can hear the sound which are in the range of 20 hertz to 20,000 sound. So those sound who those sound whose frequency is less than 20 hertz, whose frequency is less than 20 hertz is called infrasonic sound. Okay, so I think you heard the infrasound because so do you know that the bats are actually bats do not have any eyes like humans. They actually use the infrasonic sound. So what they did, bats generally send a infrasonic sound. Okay, and then sound uh, reflect to the nearby object. Okay, and they again after reflection they reaches the bat's ear. Okay, in this method they can visualize the nearby objects. Okay, so bats are generally used in infrasonic sounds, and those sound whose frequency is greater than 20,000 hertz, they are called ultrasonic sound. Okay, so the ultrasonic sound are generally used in to detect the babies, to detect the babies in uh, to to detect the gender of a pregnant lady. Or now what is unit of sound? Now unit of sound means actually we generally measure the loudness of the sound, and it is measured in decibel. So the its unit is decibel. So there is another unit is called Weber per meter square. Okay, but in general decibel is used. So our actually mm, our have the above 90 decibel sounds are generally termed as noise. So you should hear the sound which is up to 90 decibel. Now there are some their intensity of some sound are given. The threshold of pain is 120 decibel. Busy traffic, sound of busy traffic is 70 decibel. You can the sound of intensity of conversation is generally 65 decibel. Whisper is 20 decibel. Okay, and so on. And so on. Now, reflection and absorption of sound. Now, like light, sound is also reflected and absorbed. Okay, so we know that there are some laws of reflection. Okay, so the sound wave is also follow the laws of reflection. Okay, now as you know that the light for reflection of light we need a smooth surface. So similarly in case of sound wave we need a smooth and hard surface for reflection sound. So for example metals, walls, these are the good reflector of sound. But the soft things like your cloths, sponge, these are not good reflector of sound. They're generally absorb the sound wave. Okay, now there is a one activity to check if sound obeys the laws of reflection or not. Now in this activity, here we have a plate. Okay, so and here we have two pipes. Okay, hollow pipes. Now in one end, okay, so between these two pipes we have placed a screen. So in one end of this first pipe we have placed a clock. Okay, now you can arrange this second pipe in any other way. So you will observe that when these two angles will be equal, at that point you can hear the sound of this clock. Okay, suppose this angle is 30 degree. So at a particular 30-degree angle here, you can hear uh, you can hear the sound of this clock. Okay, if this angle is not 30 degree, 31 or for 35 or 50 degree, you cannot hear the sound, because we know that the laws of reflection, which incident angle must be equals to reflected angle. Okay, so at the 30-degree angle, when these two angles will be equal, at that particular angle you can hear the sound of this clock. Okay, this experiment shows us that the sound is also follows the laws of reflections. Now what is echo? So echo means if you hear your own voice repeatedly, that is called echo. So have you observed in Discovery Channel or in any other that a guy goes a guy shouts from a hill, and he hears his voice repeatedly. He shouts hello, and he again he hears hello, 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 hello repeatedly. So these are actually echo. Echo means whenever you hear your voice repeatedly, that is called echo. Okay, the definition of echo is: an echo is the reflection of sound that reaches a listener with a delay after the direct sound is heard. Okay, echo is the reflection of sound that reaches the listener with a delay after the direct sound is heard. So the question is, why we cannot hear the echo in the ordinary room? So can you hear your echo in your house? So you can hear your echo if the room is very large, if you're in a very large room, but in ordinary room you cannot hear echo. Do you know why? Because our human mind can hold a sound up to 0.1 second. Suppose you are inside a room. Okay, so here you are standing. So you are saying something. Suppose you are saying hello. So when you are saying hello, that sound instantly goes to your ear, and you can hear the your voice. Now now this sound also strikes the strike the walls of your house. Okay, it spread all the directions and strikes the walls. Okay, now after the reflection from the wall, this sound again reaches to your ear. Okay, so reflected sound always reaches to your ear, but in generally what happens, the original sound, when you speak, your original sound goes to your mind, and the reflected sound, the time between the original sound and reflected sound is generally less than 0.1 second, and your mind cannot distinguish between these two sounds because their time between the original sound and the reflected sound is less than 0.1 second. So that's why you cannot distinguish between them. But if somehow your house is very large, and if this reflected sound reaches your ear after 0.1 second, then your brain can distinguish between these two sounds, and then your brain then you will hear two different voices, your own voice, but two different two your own voice, but two times you can hear your voice two times. So so the condition for the condition for the echo, that the time between the original sound. Okay, so when you are speaking, the sound directly goes to your directly goes to your brain, so that is the original sound. And the other sound, that is when this sound is reflected from the walls and then again reaches to your ear, and then your brain is processing that sound, that is the reflected sound. That the so the difference between the original sound and the reflected sound must be greater than 0.1 second, 0.1 second, or greater than 0.1 second. Okay, now the question is, what should be the minimum distance to hear an echo? Okay, what should be minimum distance to hear an echo? Suppose again, we'll consider, suppose you are standing here. Okay, so there is a wall. You're saying something. Okay, and you're saying something. Okay, and after sometimes you can hear your echo. Okay, suppose this distance is t. So you know that distance is equals to speed into time. Okay, now to hear echo, time should be how much? Time should be 0.1 second. Minimum time should be 0.1 second. It can be 0.2 second, 0.3 second, and so on. Okay, as we increase that, it can be 0. Any, but minimum time should be 0.1 second. And what is the speed of sound? The speed of sound is actually 332 meter per second in here. Okay, but at that time sound travels how much distance? The first it goes d distance, the after reflection again it comes back d distance, so it actually covers how much distance? 2d distance. So 2d is equals to 320 into 332 into 0.1. Now 332, 2d is equal 332 into 0.1 is equals to 33.2. So d is equals to 33.2 divided by 2. If you calculate, so if you cut 2 ones are 2, 3, 2 6 are 16.6. So minimum distance from the source to the observer, minimum distance should be 16.6 meters. So if you are standing, so 16 if you are 16 if you are standing 16.6 meter far from a wall, then that means at that point, at that time, you can hear your echo. Okay, so minimum distance should be 16.6 meter. Okay, from the reflector. So here it is given where okay, so minimum distance would be 16.6 meter. So that means we can hear an echo only when the reflecting surface is beyond 16.6 meter from the surface. Now what is sonar? Sonar is actually the application of reflection of sound. So actually what happens, the actually this so ships generally send a high frequency sound wave. High frequency, you can assume that they send actually high energy sound wave. Okay, so this sound wave goes all. So actually the sonar is used to detect the depth of depth of a sea. So what happens, the ships actually generally send high frequency or high energy sound wave. So so this so this sound wave after this sound wave after reflection from after reflection from the seabed, it goes all the along. Okay, and it reaches to the so and it reaches to the ship again. Okay, so the ship has a detector to detect the reflected sound. Now what they did actually, whenever they send the sound wave, they start the stopwatch, and when they get the reflected sound, they they stop the stopwatch, and they calculate the time between when they so and they calculate the time between these two sound waves. Okay, suppose, okay, so suppose the time is suppose the time is 0.5 second. Okay, now in this 0.5 second, how much distance did it cover? It cover, if the depth of depth of the sea is d, so in so it covers how much distance? 2d distance. So 2d is equals to, so time is how much? 0.5, and the speed of sound in water is actually 1500. Okay, speed of sound is greater in water comparing to air. So in 2D distance is equals to 0.5 into 1500 is equal how much? 150 into 5, that means 750. So D is equals to 750 by 2, so that means 375. So that means the depth of the sea is 375. So in this way, I just gave you an example. So in this way, the using the sonar, using the sonar, they used to measure the depth of a sea. Okay, so the formula is same. What is the formula is distance is equals to distance is equals to speed into time. Okay, speed is denoted with v and time is t, but the distance, how much distance sound wave travels, it actually covers 2d distance. If the distance is original distance is d, it covers 2d distance. Why? Because d distance covered by original sound, and another d distance is covered by the reflected sound. So total distance covered by the sound wave is 2d. So using this formula, you have to solve the numericals also. Okay, so one numericals is given that sonar transmit ultrasonic sound waves towards the bottom of the sea. Time intervals recorded to receive the reflected sound is 1.8 second. If the speed of ultrasound in water is 1500 meter per second, find the depth of the sea. So we know the formula. 2d is equals to v into t. So the depth, we have to find out the depth. So 2d, v velocity is given how much? Velocity is 1500 and time is given 1.8. Okay, so d is equals to 1500 into 1.8 by 2. So 2 9 is 18, but you have to give a point. Okay, so 1 point, so d is equals to 1500 into 0.9. So 1500 into 0.9 means 150 into 9. So 159 is, so 1350. So depth of the sea is 1350 meter. Okay, so in this way you have to solve the question. Now relative speed of sound in different media. So what is the relative speed of sound in different media? Now the speed of sound increases as the density of the medium increases. So if the medium has the higher density, then the speed will increase, sound speed of sound will increase. Now which medium has the highest density? Obviously, obvi- uh, obviously gas medium, no. Water medium, no. The solid medium has the highest density, because you cannot put, you can put your hand inside a solid. Suppose you have a what is called, suppose you have a brick, or you have a stone. Can you put your hand inside a stone? No, because the density of solid is very, thus because solid is very dense. But you can put your hand inside a water, because the density of water is less than density of solids. Okay, or density any liquid, density of any liquid is less than density of solid, and the density of gas is very negligible. Okay, very less. So that means the speed of light, so speed of sound is maximum in solid. The speed of sound is maximum solid, and then in liquid, and speed of sound is least in air. So speed of sound is least in air, and it is speed of sound is maximum in solid. Okay, so in addition to that, there are some extra factors, uh, extra factors that in gases sound, the speed of sound depends on the temperature and humidity also. So these factors will study about about this factor in the higher classes. And in liquid, it is also depends on the pressure. Okay, so just remember, from now in the higher classes we will discuss about this. Now, to find the speed of sound in air. Now speed of sound in air is equal to distance traveled by sound. Okay, the same formula we use. We know that distance is equals to speed into time. So here in the, from some formula you can write, so you can write speed is equals to what, distance by time. So the same formula they used. So remember this as distance is equals to speed into time. So speed means distance by time. Okay, now there are some speed of sound in different mediums are given. So this so so you don't have to remember all this. Okay, just go through once, you don't have to remember all this. Now the question is, just remember the speed of sound in air is actually 330 or 332 meter per second, and speed of, so in air, and speed of sound in water is actually 1500 meter per second. Okay, remember this two. This will be enough. And speed of sound in vacuum, sound cannot travel in vacuum. So speed of sound is in vacuum is 0. Sound needs a medium to travel. Okay, but air can travel in the vacuum. Sorry, light can travel in the vacuum, and the speed of light in the vacuum is maximum. But sound can travel in, the speed of sound is maximum in solid, but light cannot travel inside a solid. Okay, so that is the difference between light and sound. Now the last topic is the last question. The thunderstorms are heard after the flash of lightning. Do you know why thunderstorms are heard after the flash of lightning? Because the speed of light is very much greater than speed of sound. The speed of light is 3 lakh kilometer per second. So in second, light travels 3 lakh kilometer, but speed of sound is 0.3 kilometer per second. So that means in 1 second sound travels only 0.3 kilometer, whereas the light travels 3 lakh kilometers. So do you know, so can you understand the difference? 3, where 3 lakh, and where is 0.3? So light is much more faster than sound. So whenever thunderstorm occurs, uh, the light directly reaches the light reaches our eye as soon as it occurs, but sound takes some time. Okay, it is very slow. So only its speed is only 0.3 meter per kilometer per second, or 332 meter per second. So it is very slow. So it takes some it takes some time to reaches our ear. So that's why thunderstorms are heard after flash of lightning. Okay, so thank you. This chapter, I think this chapter is finished. So from the next day we'll start another we'll start another next chapter, which is electricity and magnetism. So thank you for today. Thank you everyone.